So we've been talking about what it takes to industrialize, about Britain industrializing in what industry? Textiles. Okay. Let's quickly review what it takes to industrialize. What are those ingredients to industrialization?
Natural resources.
Abundant natural resources.
Population.
Adequate population in the right places. Transportation system. Adequate financial capital. Stable government. You got to have those 5 or it's not going to come together. Entrepreneurship, yeah, you've got to have somebody willing to take that risk, but I kind of, in my mind, I roll that into the banking system, the financial capital. All right, so we've already established that Great Britain is the first nation to industrialize. Everybody else comes after. Who was the first nation on the continent to industrialize? Belgium does. What industry? Textiles as well. Textiles as well. It's a fairly easy industry to industrialize because the industry itself already existed. It was just a cottage industry, and all they had to do was develop the factory system to move it into. A lot of you missed that first question on the quiz. Factory system is what emerges. Okay? All right. So the United States industrializes? Yes, because we watched a video about it. The United States had plenty of abundant resources. And how did the United States figure out how to industrialize? We stole it. We cheated. We copied. Right. We followed the example Great Britain set out, which is what everybody else is going to do. I mean, if you are the first one to wear the cool new shoes, jeans, hat, coat, glasses, whatever to school, anybody else who does it after you is copying you. Okay, Germany doesn't exist at this point in time as a nation. It's not going to exist until the late 1800s. But looking forward into the future, when Germany does industrialize, they do so because they have plenty of resources, and they too will copy Britain and Belgium and the United States by that time. What nation during the 1800s and the early part of the 1900s never industrializes during the 1800s and struggles to industrialize after the turn of the century? Russia. Surely Russia had plenty of resources, right? They're huge. How could they not have somewhere everything they need? And they do. They have plenty of resources. Do they have adequate population? In the cities? In some cities, yes. Do they have adequate financial capital? Russia's got some money. Russia's got some money. Do they have a good transportation network? No. Yeah, they don't. But that's not what really keeps them from industrializing, because they have a pretty good river and canal network in the western part of Russia.
Did they not have a stable government?
They did not have a stable government. And I know you're going to say, no. You said the Romanovs were the only ruling family, and they ruled clear till the Russian Revolution, which means they're in power all through the 1800s. Just because you have a continuous dynasty doesn't mean your government is stable. Because beginning with Catherine, what do we know was going on in Russia? Uprisings and rebellions and stuff. Remember, she was about to eliminate serfdom. And then they rebelled and she went, ah! Put her foot down. Well, just because you put your foot down on one mouse or on one roach doesn't mean that there aren't others out there, right? Lots more rebellions. And so Russia is too busy trying to hold itself together to devote energy and resources to industrializing. Okay. They are unstable. I'm sorry, this is a little hard to read. The gold is not as bright as it used to be. Looks great on my screen. Sorry. All right, Japan. Japan's a weird one. Why is it blue, Hoke? Well, what does Japan lack right away? Definitely, they lack land. Resources. It's a bunch of volcanic islands. They are lava rock and a little bit of dirt. There's not, unless you're the Flintstones, this is going to be hard to turn into a factory, right? Let's make rocks. Okay? So without abundant resources, Japan has virtually no chance of industrializing. What's Japan going to have to do to ever industrialize?
Then they go take over parts of
Well, it's going to have to trade. It's going to have to get those resources from somewhere else. From somewhere else. Ben, what you eating back there? Trail mix. I love trail mix, but my mommy won't ever buy trail mix for me. And Ben loves Twinkies, but his mother is a health food nut and won't let Twinkies in the house. So every day at lunch, I trade my Twinkie to Ben and I get trail mix. And this is a very happy relationship. We've been doing this since we're in like 2nd grade, right, Ben? Yeah. That's right. So we've been doing this forever and ever and ever and ever. And last year, I started dating Ben's best friend. Will and I started dating. And then Will didn't get me a very good Christmas present, so I kind of dumped him. So guess what I'm probably not going to get at lunch today? I'm not going to get my trail mix because Ben doesn't want to trade with me anymore because he doesn't like me anymore. So as a juice cleanse, okay. I'm out of luck. I have to find somebody else to trade with who wants my Twinkie, because that's what I've got to offer, and who has trail mix to trade. It puts you in a vulnerable situation. Japan undergoes a huge period of political change because Japan had not been interested in industrializing. They're going to undergo a big period of political change, and when they come out of that, by the way, it's called the Warring States period. We're going to talk about it a little later in class. Not today, but a little later in time. When they come out of the Warring States period, there's going to be a new empire, a new dynasty ruling Japan, and it's going to be called the Meiji Empire. The Meiji Empire is a big stinking deal. Okay? Because when the Meijis come to power, when they get the Warring States period ended, they've unified Japan, they've got their new dynasty, they say, we are going to industrialize. Boom. They don't necessarily do it the way Peter the Great did. They don't say we're going to westernize. They say we're going to industrialize. And what that means is they first need to start acquiring those resources. Foreshadowing for you in history, since we've established that Japan has virtually no resources of her own. She can fish. Japan can grow rice. Okay? Japan needs to either trade or acquire territory full of resources. And one of the things Japan is going to do very early in the 20th century is acquire a hunk of territory on the mainland of Asia. Piece of territory previously known as Manchuria. They will change its name, they'll call it Manchukuo. And that will be the first step in what Japan plans to call the Greater East Asia Co-Prosperity Sphere. The Greater East Asia Co-Prosperity Sphere. And to realize that, they're going to start acquiring other pieces of territory. And what's going to put them over the edge is that Japan needs fuel to run her industry. And we, in resistance to Japan's acquisition of territory under the Greater East Asia Co-Prosperity Sphere, we, the United States, will say, no oil for you. We embargo our trade of oil with Japan. Japan gets a little sore at us for that. And what happens? Really? The U.S. stops trade with Japan. Japan is mad about that. And Pearl Harbor, hello, thank you. In your experience, the one time Japan has ever been mad at the United States, what happened? Pearl Harbor, World War II. Okay, so we know there are problems when a nation lacks all of the ingredients to industrialize natively. Other territories, nations that will industrialize very successfully and fairly rapidly once they decide to do so include Canada, Australia, New Zealand. What do those three have in common? What do Canada, Australia, and New Zealand all have in common? They do not all have weird accents. I don't know what you're talking about. Of their British colonies. Oh my gosh, I wonder what encouraged them to industrialize and where they got the technology to do so. And then who do you suppose is in black? The folks that almost never industrialized. It took them forever. Italy. Think about the geography of Italy. What do you know about that Italian peninsula? It's what? It sticks out into the middle of the Mediterranean, so it should have great transport, right? Why not? Why doesn't it? Has anybody ever heard of Pompeii? What happened to Pompeii? It was buried by a volcano. Did that volcano just spontaneously spring up just to bury Pompeii? The entire spine of that Italian peninsula is mountainous. So you have a long, skinny country with mountains down the middle. Makes it pretty difficult to build roads. Makes it nearly impossible to build railroads because you got to go through the Dolomites. Dolomites? Is that the mountains? I better not say that because I'm not sure that's the name of the mountain range. Apennines. Apennines? Apennines sounds right. You got to go through them or over them. Either way, the weight to power ratio of steam engines isn't strong enough to pull a locomotive, let alone loaded train cars up and over those mountains. They don't have the ability to go through them. They're like marble and granite. Okay. So the fastest way from east to west in Italy is to get on a boat and sail around. That is not conducive to industrialization. Did you look it up, Ms. Novacek? Apennines. All right. Whew. I think the Dolomites are over in the Balkans, over in Romania. But anyway, so Italy also has another problem. Italy doesn't exist. Not until right before the turn of the 20th century. So that would kind of mean that they lacked political stability because they didn't exist. So they're going to have to be created, overcome the transportation network problem, and then industrialize. The other country that doesn't industrialize for us is China. China had that closed door policy. Foreigners, get out. Leave us alone. We don't want your stuff. It's crap. And they stayed that way. It's going to be just around the turn of the century when China's going to butt heads with the foreigners, particularly Britain, in a little conflict that we're going to study later on. It's called the Opium War. There's going to be a couple of them. And when Britain comes in and pretty much goes smack, 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 boom, to China, China's going to go, oh, we appear to have missed a little bit in the way of development in the outside world. And it's going to be at that point in time that China will look to begin to catch up. But there's a certain point at which everyone has lapped you in the mile where you begin to lose the will to try to catch up. Well, China doesn't lose the will to try to catch up, but they're so far behind that they're going to have to sacrifice a tremendous amount to catch up. And that's going to cause a lot of internal chaos in China, and we'll be studying that later. So lots of, remember this? Ooh, look to the future in this chapter. Lots of foreshadowing going on with these industrial changes. All right. So in terms of stealing for industrialization, the Bessemer process is huge. Prior to this, we've got iron. We had a little bit of steel. The steel was stronger than iron, but it's very hard to produce. It's very expensive to produce. Henry Bessemer comes up with this mass production way of hardening steel, super strong. Now the things that had been made out of iron, like railroad tracks, can be made out of steel. And they don't warp under heavy weights, and they don't go out of shape under high temperatures. They don't break down as fast. Bridges last longer. Buildings, frames last longer. We're going to get skyscrapers thanks to Mr. Bessemer. Holy cow, talk about changing the world, right? So the Bessemer process is going to be applied, and we're going to be able to use this throughout industry. Huge, very key. Surprised that people weren't fighting over who got to do the Bessemer process for their papers. All right, chemistry. Just as things are changing in industry, there's a ton of research in science. And science becomes enmeshed with industry. And the things that science discovers can be immediately disseminated thanks to the Industrial Revolution. Anybody know who this handsome fella is? It's quite the looker. He really sets the world on fire. It's Alfred Nobel. It's Alfred Nobel. He is a Swede who comes up with a new invention. He calls it dynamite. And he invented it to be used in what industry? Mining. Mining. Prior to Nobel, to blow up big chunks of rock to help do tunnels and help deepen mines, they were using a thing called liquid nitroglycerin. Highly volatile. Like sneeze and it blows up and you're gone. Okay. Watch some old westerns and they'll be carrying a box of liquid nitroglycerin bottles, and they're like clink, 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 and everybody's like, we're gonna die. Okay. So Nobel takes that and solidifies it, wraps it up, puts a fuse on it. You can control when it's gonna blow up. You can control how much power it's gonna blow up with. It is awesome. It saves a ton of lives at first in the mining industry. And then some genius takes a look at this and goes, cool. I bet we can kill people with this. And they start using it for war. Putting it into mortars and shells, and eventually hand grenades. Time delayed. Perfect for that. Nobel is devastated at the destruction of mankind that is wrought with his invention, which he thought, he truly believed would better the lives of men. And instead it's taking the lives of men. So he takes the tremendous profits that he's garnered and he creates a foundation which begins awarding the Nobel Peace Prize, directly opposite of what his invention ended up being used for, right? Since then, there are lots of other Nobel Prizes that are awarded in science and medicine, chemistry, economics, literature, all sorts of stuff. But thanks, Mr. Nobel. This stunning fellow, Charles Goodyear, Yes. comes up with a process, the rubber that you are walking on today. Check out the soles of your shoes. The rubber you're walking on. Anybody got shoes that are more than a couple days old? Yeah, mine are months old. Without Mr. Goodyear, you wouldn't. The rubber that comes from the rubber plant, very soft, very pliable, breaks down very quickly, not durable. Goodyear comes up with the process of vulcanization. It didn't mean that you had to have pointy ears in order to manufacture rubber. It comes from the mythological Vulcan, the god of the forge and fire. You heat the rubber, and through a chemical process, you harden it, you add some stuff, you make it far more durable. You would not be going on cross-country road trips. We would not have trucking and 18-wheelers without vulcanization and Mr. Goodyear. So thanks, Chuck. And then Justus von Liebig. We have Herr von Liebig to thank for the plenitude that is on your plate. Okay? Herr von Liebig gives us chemical fertilizers. Prior to Herr von Liebig, we understood the concept of fertilization. In fact, we were pretty good at it. We used poop. Your poop, my poop, animal poop was all good. It made the plants produce more and grow faster and be stronger. But there's a limit to how much poop you can produce. And there's more people and more mouths to feed. Von Liebig says, let's examine this poop. It was a dirty job, but somebody had to do it. And figure out why it makes the plants grow. And then he manufactures the chemicals that make the plants grow, and you go out and you apply them to the plants. And thanks to Herr von Liebig, we have a huge population boom as a result of the introduction of chemical fertilizers. Boom. So much better than poop. It's not how he died, though. Okay. Progress always sparks change. Who are we going to talk about now? Faraday. Michael Faraday. Michael Faraday creates the first electric motor. And after he creates the first electric motor, he creates the first dynamo. A dynamo generates electricity. I am shocked that of my 70 World Civ students, no one is doing Faraday. I have 3 people doing the light bulb, which is utterly and completely meaningless without Faraday. Right? Right? Faraday gives us the dynamo which develops or which generates electricity. Anything else that you do that is invented that uses electricity, Magic Mike here is the guy. I have no idea whether he danced at one time or not. But. All right. Interchangeability and mass production. We're going to talk about a guy that you've heard of before. He gets credit for something that he didn't quite invent himself. Eli Whitney. Eli Whitney, we've talked about him in respects to the cotton gin. He's often given credit for coming up with the concept of interchangeability and mass production. Well, he did present to the Army the idea of interchangeable parts in weapons. He said if something goes wrong, how nice it would be to have an identical part to be able to pop in there, to replace it on the fly. Because up to this point in time, gunsmiths made weapons They made all of the components of one gun at a time and they put it together. And they made those pieces to fit each other. And so if you had a revolver and the chambers went bad on it, you had to take it to a gunsmith and he had to custom make that new part for that gun. You didn't just, contact Amazon and have them send out a new one and pop it in yourself. Didn't happen. The Army is like, yeah, this is a good idea, but it doesn't happen. It isn't implemented. Not by Eli Whitney. The fella who should get credit for this is Mr. Singer. Mr. Singer and his sewing machine. Because he says, oh my gosh, totally. If all of the parts were the same, I could do this in a factory and nobody would have to know how to do anything more than you put your piece there and then hand it off to the next guy. And you put your piece there and hand it off to the next guy. You don't have to know how the machine works and file things down and make them fit just so. You just assemble. Because he uses interchangeability, he is able to produce in huge numbers, thus mass production. When you can produce in huge numbers, that brings your costs down, which means that the cost of the good to sell to the consumer is way cheaper. Singer, because he uses interchangeable parts and mass production, gives us two more innovations that change American society. He takes out full-page ads in newspapers and magazines, which are new at the time. Full-page ads advertising the wonders of the Singer sewing machine, how reliable it is. But it was still expensive for everyday people. By the way, first new innovation, the advertising industry, thanks to Mr. Singer. Second new innovation, when he's advertising, he's telling you how you can get your hands on this even though you can't afford it. 10 cents down, 10 cents a month. The installment plan. It's not credit cards yet, but you are buying your Singer sewing machine on credit. Thank you, Mr. Singer, for making the USA a debtor society. After Singer's success with this, other manufacturers can't wait to give consumers their goods before they've paid for them. Changes the way the world works. Now, we have to get these goods from the factory to the people. And that changes hugely because of the Industrial Revolution. Before the Industrial Revolution, we've got these guys, clipper ships, or this one is particularly called a bark. A little bit of cargo space, pretty fast for the day. We get to the point where we're even making these out of iron sides. Lots more durable. Okay. But as soon as the Industrial Revolution comes along, we're going to change things. And away goes the sailing ship. And in comes the steamship. We take paddle wheels and steam engines and throw them on ships. We leave the sails because the sails are a nice power boost. This doesn't produce a ton of power. But we can still move even when the wind's not blowing. That's huge. This, guys, was the USS Alabama during the Civil War. Becomes a passenger steamliner up and down the East Coast. What next? What else changed? What? Oh, too far, too fast. Oh, too far, too fast. We're still middle of the 1800s. Transcontinental Railway completed in the United States in 1869. Start in the Omaha, Nebraska and head west. Start in Sacramento, California, head east. They meet at Promontory Point. We were not the first to have a transcontinental railroad. Well, not really, but kind of. Because Britain is islands. Their rail network was completed long before this, was pretty extensive long before this. And we had a pretty good rail network in the eastern part of the country. The west just wasn't settled yet. But I tell you what, once this was done, boom, like crazy. It's another 3-4 years and we've got a southern route, and another 5-7 years after that and we've got a northern route. And then they connected them all north and south and in between. Crazy. The Trans-Siberian Railway. This is huge. This one is huge. There had been a line from Moscow to St. Petersburg completed in 1851. They did that before we even got our Transcontinental Railroad done. 40 years later, 1891, they finally start building this rail line from Moscow to Vladivostok. They do the same thing we do. They start on both ends and build in. Except there's not a lot of resources or people out here to build in, so they built west more rapidly, or built from the west more rapidly. Start in 1891, sorry. They will complete it in 1904. It takes them 13 years to build this railway. That's a long, long time. From 1897 to 1916, they had gotten out here, just west of Ulan-Ude. Do you see this blue here? That's a big, huge lake called Lake Baikal. Along the southern side of that lake, the ground is very swampy. So when they would put train tracks down, it seemed fine, and then they'd run a train over the tracks, and all that extra weight and motion and stuff, derailments, crashes, bad, 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 bad. So they're like, okay, can't fix that. It's, permafrost after all. It's a mess. So what they did is they sent to England, they said, build us 2 steamships. They were what were called piece built. They built the steamship, they tested it, everything. And then they took it apart and they numbered every piece as they took them apart. And they packed them into crates and they shipped them over to Russia. And they rowed what was completed out to Lake Baikal. And they get there, and they sent along some tradesmen, and they begin to reassemble those 2 steamships that they ordered from Britain. When they get them assembled, they put them on the lake, and they start building a railroad ramp up towards the edge of the lake. And on the decks of those steamships, they installed rail lines. And a locomotive would pull onto the ferry. It's basically what it was. The locomotive would pull onto the ferry, a locomotive and up to 24 train cars. And then it would sail across Lake Baikal and off the ramp on the other side. And then the ship would go back, repeat until you got the whole train across, and then it could continue. Today, if you go and ride the Trans-Siberian Railroad, which you can do, it'll take you 8 days to get from one end to the other. Can you imagine back then what it would take? 1916, they eventually complete a rail line that goes up around the northern side of Lake Baikal where the ground is more stable, and they will eventually dismantle those steamships. One of them will be used in the Russian Revolution. They'll rebuild it up off the western coast. This is still the world's single longest continuous rail line from Vladivostok to Moscow. They have since expanded it. You can get on the train in Beijing if you can get all the right visas and stuff. You can get on the train in Beijing and ride it all the way to Hamburg, Germany. They did this for freight purposes. At the fastest, on the best express train, 25 days you can move your cargo from Beijing to Hamburg. Generally closer to 2 to 3 months. Still not great fast. We are going to talk about the Trans-Siberian Railroad again later, especially when we talk about the Russo-Japanese War, but we're going to move on from that now. By 1913, this is what the rail network in Europe looks like. Pretty good, huh? It gets there. You can pretty much go anywhere you want, huh? In Asia in 2009, a century later, this is your rail network. Now, the reason there's a big hole there in the middle has to do with a bunch of granite outcroppings called the Himalaya Mountains. But why? What? Why? Well, desert. Yeah, the Gobi Desert here. Lots of political differences. Geography is difficult. And by the time we had this here, what comes next? Aircraft. And so much of this is coastal. Nicholas Otto gives us the first gas-powered internal combustion engine. It had so little power you wouldn't have been able to mow your lawn with it. But it was a gas-powered internal combustion engine, and it got people started, got them thinking. In fact, along comes Carl Benz, who takes a gas-powered internal combustion engine, puts it on 3 wheels, and it is the first automobile. A little bit later, a guy by the name of Daimler is going to take that same concept and put it on 4 wheels, a little more stable. He and Benz will partner up, Daimler and Benz will partner up and will produce and form Mercedes. And so for those of you who have mistakenly been informed or believed that Henry Ford invented the car, are wrong. Carl Benz, Daimler, comes from Germany. I know. Your whole world is destroyed, right? Next thing you know, George Washington didn't chop down the cherry tree, which he didn't. Nor did Abraham Lincoln build by hand the log cabin in which he was born. Now, what Henry Ford did do is give us what invention? The moving assembly line, where the people don't move, the stuff they're building moves. And what Ford is able to do with that assembly line, this is actual Ford Motor Company footage from their archives in about 1913 on the Model T assembly line. Model T was Ford's flagship car. He was able to bring costs down so much using this manufacturing method that his workers in the factory could afford to buy a car. It was pretty much optionless. You could get it in any color so long as it was black. Do you know why black was the color you could get it in? Nope. Henry Ford was an efficiency expert as well. He tried other colors. He liked other colors. He was a fan. But the black paint dried fastest, and it meant he could keep his assembly line moving. So that's why you could get your Model T in any color, so long as it was black. And then, you guys wanted to go here a while ago, the Wright brothers, Orville and Wilbur. Do not let anyone ever tell you that you are looking at footage of the first ever airplane flight. There was not a moving picture camera on the beach at Kitty Hawk, North Carolina. There was only a still camera. So if ever you see someone claiming this is original footage of the first flight, they are selling you a bunch of hokum. Not possible. This is a later flight where the Wrights were asked by the U.S. military to develop a military-grade, more durable airplane and see what applications it could be used for. So this is 1909, just north of Washington, D.C., in Alexandria, Virginia, at Fort Myer, where our Joint Chiefs of Staff live now. It's literally right behind Arlington National Cemetery. So, pretty cool stuff. There's barracks up there on the hill you can even see. All right. It was convenient that they made that just in time for World War I. Communication changes because of the Industrial Revolution. Samuel Morse gives us the telegraph and that little clickety code that we use to communicate along the telegraph, Morse code. By the way, on whose shoulders was Samuel Morse standing when he developed the telegraph and Morse code? What are we interrupting when we tap that knob on the telegraph machine? Electricity. So who is Morse dependent upon for his invention? Faraday. Very good. All right. So, telegraph works so well, Abraham Lincoln would actually leave the White House during the Civil War and go down and he had a cot in the telegraph office so he could read the most recent dispatches coming in from the front. Pretty cool. We can communicate over distance with the telegraph, but it means so much more when I can hear you say it, darling. Alexander Graham Bell. His wife is deaf. The telephone comes out of his attempts to find a way for deaf people to be able to communicate over distances. Now, it is ironic to us, yes, that deaf people cannot communicate over the telephone, and yet that's what Bell's greatest invention is known for. But he was trying to find a way to use electrical impulses to help the deaf communicate. Didn't work out that way, but here he is placing the first call from Washington, D.C. to Chicago in 1892. 1892. So we get the telegraph in 1844. We get the telephone in 1876. We get long distance in 1892. We had long since had long distance telegraph. As they were building the Transcontinental Railroad, telegraph line went right along with them. So much so that when they drove the Golden Spike in Promontory, Utah, they had telegraph wires attached to that. And so across the nation, wherever anybody was on the telegraph, when they went, boom, it went chink across the nation, and everybody knew that the Transcontinental Road was complete. So they had a telegraph cable across the Atlantic. We could communicate almost instantaneously with anybody in Britain, and then eventually they ran one across the Channel, and we could communicate with England, or with the continent. It's hard to put an exact date on this next fella. He does it on a small scale, 1894, 5-ish. Actually demonstrated for the public over real distance, 1897. Who is this? Marconi, the radio. He was an incredibly young man. He was not even 20 when he first created his first working radio. First thing he did was he created a lightning detector in the attic of his parents' home. They were not wealthy. He basically drove his parents into poverty with his research. He was able to show his father that he could make the lights flicker when it lightninged. Electricity moving over distance. And then he was able to operate a switch across the room in one room. And then his first public demonstration is 1897 in England. He transmits sound across Salisbury Plain. And then the next year he transmits sound across the English Channel. And it won't be long before he sails across the Atlantic. And while he's doing so, he installs a radio transmitter on the ship that he sails across on. And as it's returning to England on its return voyage, it announces its return to England from 66 miles off the coast by radio. And it is because of Marconi that the Titanic was able to call for help, and that the Carpathia was able to receive that and come and rescue survivors. Radio has had a huge impact as well. Do not neglect the end section of the chapter, or end section of the section about business and corporations and monopolies and stocks. All of that stuff is still very valid. It's just well enough explained that I didn't think I needed to go into it. But you might want to know about Mr. Rockefeller and monopolies. It's on the quiz. Questions? No questions?